Good day, learners. Welcome to the presentation, which of your grade 10 presentation on the atmosphere. Under the atmosphere, for study area, we'll be looking at the composition of the atmosphere. And by composition, we'll be looking at the different constituencies which make up our atmosphere. And also, in addition to the composition, we also want to look at the structure of the atmosphere. By the structure, we'll be looking at the different layers which make up the atmosphere. All right. So before we venture into the discussion in detail, we want to start by simplifying what the atmosphere is by defining that geographical concept of the atmosphere. All right. Basically, we can define the atmosphere in simple terms, in the most simplest terms, is the layer of gases surrounding the Earth's surface. Right, if I can take you back maybe briefly, if you can still remember the internal structure of the Earth, we'll be looking at how the different layers that make up the Earth are arranged from the Earth's surface, getting into the interior of our Earth. But in this instance, when we are looking at the atmosphere, we are now looking at that layer which is composed of gases and suspending particles above the Earth's surface, meaning to say from where the different continents are located, we are in the atmosphere because we are exposed to the different gases which make up the outer part of our Earth's surface. That is basically what we refer to as the atmosphere. Right. And we also noted that the density of gases decrease with height as one moves away from the Earth's surface. Right. Meaning to say that we also tend to find that the gases that are in the upper atmosphere, they are less denser than the particles of gas which are closer to the Earth's surface. Right. It implies that less dense material tends to suspend in upper atmosphere than more denser material, which tends to accumulate close to the Earth's surface. So the concentration of air particles which are denser is more concentrated close to the Earth's surface. And as the density decreases, it tends to imply that the particles will suspend in upper atmosphere. That's the intention, that's the translation of that fact that the density of gases they will decrease with height as one moves away from the Earth's surface. Right. We said we want to start by looking at the composition. Given now that we have defined what the atmosphere basically is, we now want to go and look at the composition. And we said by composition, we are looking at the different constituencies which make up the Earth's atmosphere. Right. In the first instance, we said the Earth's atmosphere is composed of some solid particles. Some solid particles, we are referring to particles like ice, particles like salt, smoke, carbon, and dust. Those particles, basically, they come from the Earth's surface. Then give example of smoke as one of the solid particles which are found in the atmosphere. When people do the different activities, like when people cause wildfires, when people use the different modes of transportation, burning the different forms of fossil fuels, those fuels, they tend to release some smoke as they burn. That smoke will suspend and accumulate in the layer of gases which suspends above the atmosphere. And also we can talk of maybe dust particles. Dust particles coming from the Earth's surface. We can give an example of when we have a dust storm. When we have a dust storm, it means some soil material which is in the finest form of dust is taken up into the atmosphere and it gets suspended in the atmosphere. So it becomes a part of the materials that make up the atmosphere. So we have talked of smoke as one of the aspects. And also we can talk of dust as some of the particles. And also we can talk of carbon, ice, and also some salt material can also be found as suspending particles or solid particles which make up the atmosphere. Right, then we go to number two, aspect number two, which is a constituent of the atmosphere. We have the liquids, and this liquid here, we are referring to water. We also tend to find that in the atmosphere, we have water accumulating there in the atmosphere. Right. And in this instance here, if you're talking of water in the atmosphere, our core focus, remember, we'll be referring to mainly the water vapor. The water vapor, which comes from evaporation process from the different water bodies. We have the different water bodies from which when there is evaporation, that gaseous water gets to suspend in the atmosphere in the form of water vapor. So we also have liquids in the atmosphere, predominantly in the form of water vapor. Right. And lastly, we have gases. Our gases are also prevalent as a constituent of the atmosphere. They are also found in the atmosphere as one of the major constituencies which make up the atmosphere. And under these gases, we need to make a clarification. Number one, we have what we call permanent, and number two, we have what we call variable. Right. And what we call permanent in other instances is also called constant. Right. What it means here, when we're talking of permanent gases, we're saying those gases, they do not change in their composition content, meaning to say they are permanent in the atmosphere, they do not change, and they are constant in terms of their constituency. Like if you were to look at them using percentage, their percentage does not change from a given symbol of the atmosphere. Their percentage maintains the same. Those are what we call the constant or the permanent gases. Then we also have what we call the variable. When something is variable or something is varying, it implies that it changes. Meaning to say, the composition of such gases, which we regard as variable, it changes from time to time, from space to space. Meaning to say, if we take a symbol of the atmosphere, the amount of gas that we are going to find at a given geographical space might not be the same as what we will find at some other given geographical space. That is the variable part we are talking about here, or the changing part. The gases, they do change in their constituency or in their levels of composition. If you are to express them maybe as a percentage of the total of the whole atmosphere, you tend to find that they vary from place to place, which is geographical variation, and also they tend to vary from time to time. Right, that is basically what is of concern to us in summary as the constituencies or the composition of the atmosphere. What we need to do now, given that we have seen the picture of what makes up the atmosphere as the constituencies of the atmosphere, we need to progress and look at how those different components contribute in terms of the levels of their contribution as a percentage to the total amount of components in the atmosphere. Right, I will go to the gases in the atmosphere. We mentioned that under gases, we specifically have gases which we regard as permanent or which we regard as constant, and those that we regard as variable gases. Right. Our major gases which are okay as permanent in the atmosphere, we have nitrogen and oxygen. And also we tend to have argon, which is also regarded in most instances as one of the gases which are regarded as noble gases. Right. Let's start by looking at the gas which we regard to as oxygen. As nitrogen, we start with nitrogen in this first instance. Right. If we check our nitrogen, it's indicated that nitrogen has got a constituent of 78%. It has a fixed quantity of 78%. Given that we said it's permanent, it means that it maintains its level or it maintains its content composition in the atmosphere. Its content composition is pegged at 78%, which implies that is the major constituent of the gases in the atmosphere. Is the major constituent with 78% of composition in the atmosphere. And we also mentioned that we have oxygen. Oxygen is at 21%. And that 21%, that's the composition content for oxygen as one of the permanent gases. Then lastly, our argon is at 0.9%. So basically, those are some of the major gases which we regard as permanent or constant gases in the atmosphere. And we can proceed to look at what we call the variable gases in the atmosphere, right? Our variable gases, you can see here, they are coming in the form of water vapor and carbon dioxide. Those are the two major examples of our variable gases. Right, we mentioned about water vapor being a constituent of the atmosphere, and we mentioned that water vapor comes from the evaporation process from different water bodies predominantly, and also it can come from evapotranspiration from the different forms of vegetation. Right. It means the content of water vapor in the atmosphere does not maintain the same. The percentage composition does not maintain the same. Why does it differ? Right, you tend to find that it differs from space to space, and also it differs from time to time, given the different weather elements that will be experienced on a different geographical space and at some different time. So what will happen here, if, for example, we are having higher temperatures and maybe we are having a free flow of wind, those factors, they will facilitate high evaporation rates. And it will mean that the composition of water vapor in the atmosphere at that particular geographical space will be higher because we have weather elements which are facilitating the evaporational processes, which contribute towards the composition of water vapor in the atmosphere. If they are non-existent, it also means that the level of water vapor will be limited. Say, for example, we are in a colder region. Colder regions, they are predominantly occupied by cold air masses. And cold air masses, you know that they will be dry. So the content of water vapor in the atmosphere will be limited in those regions, while it will be higher, like, for example, in warmer regions, because evaporation rates will be also higher. So the level of water vapor in the atmosphere tends to vary from time to time and from a geographical space to another geographical space. That is with water vapor. Right. And then we can proceed to our next constituent, which falls under that component of variable gases. We said we also have carbon dioxide. Right, carbon dioxide with a chemical presentation of CO2. Right. We are saying here for carbon dioxide, what happens with carbon dioxide? Predominantly it's released from the burning of fuels, and also carbon dioxide is a variable gas in the sense that the processes which lead towards its contribution in the atmosphere, they tend to differ from space to space and also from time to time. Let's give an example of the burning of fossil fuels. Right, maybe you can check compared to geographical spaces, an urban industrialized area versus a rural setup, the countryside. You tend to find that the concentration of carbon dioxide will differ because of the different activities which dominate in the given geographical space. If, for example, we're having an urban area, an area which is industrialized also, you tend to find that the level of burning of fossil fuels will be much higher compared to the countryside. We have so many forms of transport which will be moving around burning fossil fuels. We have industries which will be operating. Those industries will be contributing also towards the production of carbon dioxide as they burn the fossil fuels. So the concentration will be higher if we were to take a sample of the atmosphere from an industrialized area with compared to the rural countryside. So it's also a variable gas which tends to differ in composition from time to time and from given geographical spaces. That is with carbon dioxide. Then the graph to the extreme right is just giving a summary of the different compositions of the atmosphere using a pie chart presentation, where you can see that our nitrogen is indicated here as 70%, 8%, which is taking the bigger chunk of the pie chart presentation. Then our oxygen, you can see at 21%, is also taking a relatively bigger part. Then lastly, our carbon dioxide, you can see it's having the smallest one on that pie chart. And then other carbon dioxide and other gases combined together, they are contributing just 1% of that total composition of the atmosphere. So our major concern, if we were to check on this presentation, is that of nitrogen. This is the gas which is having the biggest percentage or contribution towards the composition of the atmosphere, followed by oxygen, and lastly, carbon dioxide combined with other minor gases. They all form 1% of the total composition of an atmosphere. Right. Thus, the pie chart presentation is just a summary of how those different gases contribute in percentage form towards the composition of the atmosphere. Right. Then we need to make an analysis and see why those gases are important to us as living beings on the Earth's surface. We being beneficiaries of the existence of the atmosphere. Why are those gases important, or what's the rationale for having those gases? Are they of importance to our human life, or they are just gases which have no bearing on human life? Right. If we check nitrogen, nitrogen is important for plant growth. Right. That is the rationale for nitrogen. Plant growth is very important to aid in the growth of our plants. I think if you can still remember from the previous studies, you remember that we have what we call the nitrogenous fertilizers. Right, those fertilizers, we are saying they are rich in nitrogen, and nitrogen being it the major component of those fertilizers, it means it's an important component towards the growth of plants. When you talk of nitrogenous fertilizers, right, it means those fertilizers will be rich in nitrogen, and that nitrogen is the one that will facilitate the growth of the plants. And also, if you talk of nitrogen fixing, which happens naturally, it's also a component where nitrogen is extracted from the atmosphere and is fed to the soil. And it's a very important process which results in the enrichment of soil, which is beneficial for the growth of plants. Right, that's basically what nitrogen, and we have to remember that our nitrogen, we said, is the major contributor in the percentage composition of the atmosphere, which is ranked at 78%. Then we go on to oxygen. Oxygen is important for cell respiration and for combustion, and or what you call burning. Right. Cell respiration, the respiration process. Living organisms, they respire. So for respiration to take place, we have to feed in oxygen into the system. We breathe in oxygen as living beings, which means that without oxygen, we won't be able to respire, we won't be able to sustain life, because we need that oxygen for the process of respiration. So oxygen is a key element towards human survival or towards animal survival, because of the fact that is the gas which supports the process of respiration. And also for combustion. Right, for combustion to take place, it needs to be supported by the presence of oxygen. For complete burning to take place, we need oxygen to be present in the process so that we have what we call complete combustion. Otherwise, if it becomes incomplete without oxygen, we will be having the release of the harmful carbon monoxide from the process. So for complete burning to take place, we need also the presence of oxygen. So it's a key element, or it's a key gas which is very important towards sustaining those two processes of burning and that process of cell respiration for animal life. And also, you also have to figure out where the oxygen comes from. Remember, we have the process of respiration by animals, and we have the process of photosynthesis by plants. These two processes, they interchange the gases. Respiration uses oxygen to release carbon dioxide, While its photosynthesis on the other side, it takes in the carbon dioxide to release oxygen. So those two processes are interrelated in the sense that a byproduct or of one becomes the input to the other. So the output of respiration, which is carbon dioxide, is an input on the side of photosynthesis. When vegetation photosynthesize, they take in that carbon dioxide to use it for photosynthesis, only to release oxygen at the end of the process. While the oxygen is also required for respiration, and at the end of the process, carbon dioxide is released. Right, that is basically with oxygen. Then we can proceed to our next gas, which is argon. Argon is mainly used for industrial purposes, such as welding and manufacture of electrical bulbs. It is also known as a noble gas. Right. That's the rationale of argon. It's an industrial gas. It's a gas of industrial importance, meaning to say it can be used for those different industrial purposes, like in welding and in the manufacture of electrical bulbs. And we said it's a noble gas, meaning to say it's a non-reactive gas in the atmosphere. It does not have any reaction in the atmosphere. That is why it's regarded as a noble gas. Right, we move on to water vapor. Water vapor, which you mentioned, that is predominantly coming from the process of water vapor, of evaporation. Then why is it important? For us to experience a rain formation, we need water vapor in the atmosphere. When warm and moist air is forced to rise, that moisture, when it reaches what we call the dew point temperature, it converts its form from being a gaseous state to become water droplets that we see as clouds. So it can only happen that we receive rainfall after we have a situation where we have moist air ascending to higher altitude, reaching dew point, and the moisture condensing to form clouds, which will mean that without water vapor in the atmosphere, we won't be experiencing any form of precipitation coming to us on the Earth's surface. So water vapor is very important for the climatic process of rain formation. I think you can still remember, or you can still figure out from the previous discussion, you talked about the different types of weather, of rainfall, which are realized, the likes of orographic or relief rainfall, the likes of cyclonic or convectional rainfall, and the likes of torrential rainfall. Those rainfall, if you check, they are as a result of water vapor being present in an air parcel in the atmosphere. As the air parcel is ascending, is going up towards towards higher altitudes, the temperature gets lowered and the water vapor will condense and will result in the formation of water droplets, which we see as clouds that will produce rainfall. Right, we'll move on to carbon dioxide as one of the constituents again. Carbon dioxide, we said it varies because of number of people, combustion, amount of vegetation, etc. Those are the determining factors, or the factors which control the amount of carbon dioxide. Amount of number of people, we said, remember, respiration. People respire. As they do respiration, they release carbon dioxide, which means in areas which are highly populated, it also means the concentration of carbon dioxide will be higher. And combustion, the burning process, where there is high levels of burning, like in the industries, and where there is high traffic volume, you also tend to find that the concentration of carbon dioxide will be higher. And also amount of vegetation, we said vegetation is responsible for using the carbon dioxide in the atmosphere for the process of photosynthesis, which means where there is high concentration of vegetation, the carbon dioxide in the atmosphere will be effectively used for the process of photosynthesis, and it contributes towards the reduction of the composition of carbon dioxide for that particular geographical space because of the presence of vegetation, which tends to utilize the carbon dioxide for the purpose of photosynthesis. Right. So that's basically a picture on the translation of those gases and trying to figure out how we get those gases and how they can vary if they are variable, And the rationale for the constant gases, which we said they do not change, or the permanent gases, which do not change in the level of composition of them in the atmosphere. Right. We need to move on and have a discussion on the importance of the atmosphere. What's the rationale for the atmosphere? Why is it important that we have the atmosphere covering us on the Earth's surface? Right. The first one, which is most definite, is it contains oxygen, which is essential for respiration in human. The process of respiration, we have described it prior to this. It means if there wasn't the atmosphere with its composition of oxygen, then life on Earth wasn't going to be possible. It wasn't going to be realized because without oxygen, it means humans cannot respire, and without respiration, there is no life, which will mean that the atmosphere plays a very big role in providing oxygen for the sustenance of a human life on Earth's surface, and also contains carbon dioxide. And what's the rationale for carbon dioxide, which is important for plants to grow? We said plants, they do photosynthesize, and in the process, they tend to use carbon dioxide. So it's also another rationale of the atmosphere to provide carbon dioxide, which is important towards the sustenance of plant growth. And number three, it states that it acts as a blanket around the earth. A blanket, you are looking at a cover material here. Remember, the sun produces harmful rays. The heat which comes from the sun comes in the form of what are called the ultraviolet rays, or the UV rays, which come in the form of shortwave rays. The sun's heat, the sun's radiation is regarded as the shortwave radiation, which is harmful towards human life. The shortwave or the ultraviolet rays. So these ultraviolet rays they need to be reduced in terms of their effect as they get towards the Earth's surface. If the Earth was to hit directly towards the Earth's surface, there was going to be so many complications which will be caused by the level of heating which will be having, which will be having received from the sun. So the atmosphere acts as a blanket, which means the atmosphere protects us on the Earth's surface from the effect of the dangerous UV which will be coming from the sun. The sun will be producing high levels of radiation, which will tend to affect life on the Earth's surface. But because the atmosphere is there, it will filter the impact of those UV rays to protect us on the Earth. That is why we are saying it acts as a blanket. It's a cover which is protecting life on Earth from the dangerous or the harmful effects of the UV rays coming from the sun. Then it also protects life on Earth. We are also referring to the harmful effect which comes from the radiation of the Earth, of the sun. There are so many harmful phenomena which develop in the atmosphere, which will be filtered by the atmosphere, which will mean that life is being supported by the presence of the atmosphere, and you are being protected from the harmful effects which arise from the upper atmosphere. Right. That is on the importance of the atmosphere in brief or combined picture of the whole atmosphere. Why we saying the atmosphere is important as a component of the Earth's structure. Right. And after this, we have seen the rationale of the atmosphere. We need to move on and look at the structure of the atmosphere. By the composition, we're looking at what makes up the atmosphere. What is it that is in the atmosphere? Right now, we want to look at the structure. By the structure, we're now looking at the different layers which make up the atmosphere. The atmosphere is not a uniform, it does not have a uniform structure, meaning to say it is not comprised similarly throughout, but is comprised of some different sections which make it up. So we want to look at the different sections which make up the Earth's atmosphere, right? What is indicated here is a brief picture of the layers which make up the atmosphere. Right. I will try to illustrate, I will try to explain using the diagram indicated here. Right. If you check our diagram, how the diagram should be read when you are reading this diagram, you should be familiar with what is presented on the horizontal and what is presented on the vertical axis. If you are to check here on the horizontal axis, you can see that it's temperature in degrees Celsius. It's presenting our temperature in degrees Celsius. And on the vertical axis, that is our altitude or our height. Right. So what it means here is we have our temperature readings on the horizontal axis starting from 0. This is 0 degrees Celsius. The next one is 20, 40, 60, going towards the positives. And from 0, we have negative 20, negative 40, negative 60, going towards the negatives. So it means our temperatures are ranging from extreme negative and going towards extreme positive. Right. So the first layer that we have on the Earth structure is this layer, which is called the troposphere. It's called the troposphere. That is the layer which is most immediately above the Earth's surface, on which we are situated. All continents are situated within this layer, and all human life is sustained by this layer. This layer, which is called the troposphere, is one which is lowest according to the explanations given here. We are now referring to that illustration here. It's saying the troposphere is the lowest layer. This is where we live because we are just above the Earth's surface. It means the Earth's surface is presented where these temperature markings are. Just on top of this, we are in the troposphere. And it's where weather occurs. For us to experience rain formation, for us to see cloud formation, for us to realize all those different weather elements, they do happen within this first layer, which is the troposphere. Right. And we want to analyze this line, which is indicated here. This line that you are seeing, the white line here, which is going upwards like this, is the temperature profile. The temperature profile, this is a temperature reading. We are comparing temperature on the horizontal scale, on the horizontal axis versus the altitude on the vertical axis here. So what it means here is this is a reading of temperature starting from the ground surface. Starting from the ground surface, we have a temperature. Let's say on this instance here, you can see our 0 mark for temperature is there, our 20 is there, which means our temperature here, we can estimate it at plus or minus maybe 12 or 15 degrees Celsius, starting from the Earth's surface. And if our altitude is increasing here, our altitude is going upwards in kilometers from 0 to around 10. You can see that the temperature, when we reach the 10 kilometer altitude mark, our temperature has dropped significantly to around negative 40 degrees Celsius. So this is what we refer to as a negative temperature profile, which implies that in the troposphere, if you go to higher altitudes, the temperatures are going to decrease. The ground surface or the Earth's surface has got higher temperatures than places in upper altitude. That's the temperature profile in the troposphere. It's negative, meaning to say the higher you go, the temperatures will get lower. That's the essence of the temperature profile within the troposphere. Then what will happen is as the reason as to why the temperature profile is like that, we are going to discuss it in detail when we do the heating of the atmosphere. The heating of the atmosphere gives us a clear understanding of why the temperature profile is negative. Why is it much water close to the Earth's surface than in the upper atmosphere, in the troposphere? Right. Then if we continue with the temperature profile, you see that here there is a white marking which is written tropopause. This one here is indicated the tropopause. What is it that we call the tropopause? That's the upper limit boundary of the troposphere. We are moving from one layer to the next layer. We are transiting from one layer to the next. There is a boundary which marks the end of that particular layer. So it's troposphere. Then when it ends, when we are to approach the next layer, we reach what is called the tropopause. That's the boundary, the upper limit boundary, which marks the distinction between the troposphere and the next layer. Right. After the next layer, we now move on to what is called the stratosphere. That's the next layer on the structure of the atmosphere. And if you can check here, our altitude is still increasing. The stratosphere from around 20 kilometers getting to around 50 kilometers here. Around 20 going to as high as 50. So you can see this layer is much more denser than the previous layer. The troposphere is thinner compared to the stratosphere. And it is within this stratosphere where we have what is called the ozone layer. And the ozone layer is also part of a discussion to follow, which we're going to focus on the ozone layer on its own and see its rationale, its importance, and what human activities and what humans are doing, which is contributing towards what we call ozone depletion, and the likely impacts and the strategies to avoid the depletion of ozone. That is a discussion on its own. But for the sake of discussion of the structure of the atmosphere, you should just mind that there is also the ozone layer, which is found in the stratosphere. Right. There is a concentration of that gas, which is called ozone, within that layer of the stratosphere. Then we continue. If we check the temperature profile, it's now reversing. The temperature profile is now positive in the stratosphere, meaning to say, with increasing altitude, the temperature is also increasing. If you check starting from here, our altitude is increasing from 20 going to 50. Our temperature was at negative 40, but here you can see that the temperature is almost close to 0 degrees Celsius, which means in the stratosphere, the temperature profile is now different from the troposphere. It's now positive. As height increases, the temperature will also be increasing. That's the profile within the stratosphere. Then we reach this upper limit. The upper boundary of the stratosphere is called the stratopause. That's the upper limit boundary. We are now transiting from the stratosphere. We are moving on to the next layer of the atmosphere. Right. So that's basically the stratopause. Right. And we move on to the next layer after the stratopause. The stratopause is followed by a layer which is called the mesosphere, which is the third layer as we come from the Earth's surface. Mesosphere, what happens in the mesosphere? What we should be worried about is the temperature profile. How does the temperature change with increasing altitude within that layer? Right, if you check from the stratopause here, going towards the mesopause here, which is the upper limit boundary, you can see that the temperature profile is negative. As height increases, the temperature is decreasing. And is decreasing sharply. If you try to check the temperature here, it's plus or minus 0 degrees Celsius at the stratopause. But the moment you reach the end of the mesosphere, you find that the temperature is very low, excessively low temperature to around negative 90 degrees Celsius. If you check the reading here, plus or minus negative 90 degrees Celsius. So it means the temperature drops very significantly from 0 to negative 90. That is a very big change in temperature with altitude. So that's the typical conditions in the mesosphere. Then we reach the upper limit layer, which is the mesopause. And from the mesopause, we go to what we call the thermosphere. Right, thermosphere here is the fourth layer coming from the Earth's surface. Thermosphere, it implies that this region here is having a higher temperatures, is having excessively high temperatures. From the mesopause, the temperature was around minus 90 degrees Celsius. But if you check as we go up to the end of the thermosphere, the temperatures are very high, above 60 degrees Celsius, which is still increasing with increasing altitude. There is a positive temperature profile in the thermosphere, implying that if we keep increasing altitude within the thermosphere, the temperatures will get excessively very high. And that will be the translation of the conditions within the thermosphere. And predominantly, the temperatures are caused by atomic oxygen, which is responsible for absorbing heat within the thermosphere. That is why the temperatures will get excessively very high. And if we are to look at the upper limit of the thermosphere, we again have a pause at the end, which is a thermopause. And from the thermopause, we will now be going into space, which we refer to as the exosphere. We will be now going outside the normal structure of the Earth, getting into space, which we regard as the exosphere, right, which lies outside the normal Earth's structure. Right. That was with the Earth's structure. So in summary, what you need to note is you need to note the arrangement of the different layers which make up the Earth's surface, which make up the atmosphere, starting from the Earth's surface. And number two, what you need to know is you need to note the temperature profiles in those different layers. How does the temperature behave with increasing altitude in those different layers? And also, you should mind when you are minding about the limit, the boundaries between the layers. Know that the layer on top, the upper boundary, is named after the layer below. Like if we're in the troposphere, when the troposphere ends, it ends with a tropopause. Then we go to the stratosphere, it's another layer. We are keeping on increasing our altitude. It ends again with a pause named after the layer before, which is a stratopause. We go to the mesosphere, the upper limit boundary is the mesopause. We go to the thermosphere, the upper limit is the thermopause. That is how those layers are basically arranged. Right. So to check on our discussion, we just want to summarize on the different layers and maybe give a rationale, what's their importance and how they look like, because we now have a picture of how they look like and what makes them up and how does the temperature behave with altitude in those different layers. We just now going over through a summary of the different layers, right? We start with the troposphere. The troposphere is closest to the Earth's surface. I think that is clear because we said that is the uppermost layer above the Earth's surface, the one which starts as we are moving away from the Earth's surface. And its height is about 10 kilometers around the polar region and 17 kilometers around the equatorial region, right? Which implies that the upper limit boundary of the troposphere, it differs from around 10 kilometers in the polar regions, and it also around 17 kilometers around the equatorial regions, which implies that it's higher. The upper limit boundary is higher, is already elevated in warmer regions and is lowered in colder regions. And air is densest in the layer. That is where we find the heaviest air concentrated in this particular layer of the atmosphere. And the highest amount of oxygen and water vapor. Remember, we said this is the layer which supports life. So we need oxygen and it's readily available. It's highly concentrated. And also weather processes, we said they take place in the troposphere. Water vapor is a key element towards determination of the weather patterns. So we also have it there. Then temperature decreases with altitude. It's clear. We said there's a negative lapse rate. There is a negative temperature profile, which tends to be realized in the troposphere. Temperature decreases with altitude and is separated from the stratosphere by the tropopause. I think it's also clear. Troposphere, we go to tropopause. Then the importance, it produces weather. We talked about that all weather takes place within the troposphere. The oxygen that we breathe, we get it from there. And also water vapor, which is essential on Earth for it to have rainfall. We need to have water vapor, which we realize from the troposphere. Then we also indicated that it produces water through rain. Since weather processes take place in the troposphere, it also means that we tend to find rainfall being realized within the very same layer and produces food that we eat. Remember, we said plant life, photosynthesis takes place and also respiration takes place. So, for us to have food, either we are having food from plants or we are having food from animals. For us to effectively do agriculture, we need this layer which supports plant life and also which supports animal life. Remember, on plant life, we talked about nitrogen being present in the atmosphere, in this troposphere. So, it means plant life is sustained and also the carbon dioxide sustains plant life and animal life is sustained by oxygen, which means this layer is very important. It contributes significantly towards the sustenance of life through providing food for humans on the earth. Right, and we move on to the next layer. After the troposphere, we said the upper boundary is the tropopause. Then we go to the stratosphere. It's located above troposphere. Yes, I think it's clear. We have talked about that on the profile. And it contains ozone layer. The ozone layer, we mentioned about the ozone layer. That is a layer which protects us from the harmful ultraviolet sun's rays. And that one is going to be a center of discussion on its own. The presence of ozone layer and how it is destroyed by human activities and the impact of ozone destruction and what can be done to address the issue, right? And say temperature increases with altitude, right, which is a negative. Temperature increases, then we go on to the importance of the um, the layer of the stratosphere. It contains ozone, which supplement our oxygen. Yes, and airplanes are flown in this layer, right? The airplanes, they do not fly within the troposphere, but they fly slightly above the tropopause within the stratosphere. For one major reason that, remember, we said all weather takes place within the troposphere, which implies that if it is on a cloud day, if planes are to fly within the troposphere, visibility will be very minimal. They won't be able to see through their way. So the only way to be safer is to fly slightly above the layer in which weather is taking place to avoid that issue of invisibility, which is caused by the formation of clouds within the atmosphere. So the airplanes, they tend to fly within the stratosphere, slightly above the tropopause. And we also indicated that the airplanes, they use wind in this layer to pick up speed. Remember, the flow of air within that layer is unlimited. The air flows at a faster velocity, which are going to be utilized by the planes to gather momentum and to gather speed. Right, basically, that's the importance. We can summarize the importance of the stratosphere using those three arguments. Then we go to the third layer, which is the mesosphere. The mesosphere, we are saying, it just comes above the stratopause. We go to the mesosphere. And the mesosphere is stretching from around 50 to 80 kilometers above the stratosphere from the Earth's surface, from about 50 kilometers out after the Earth's surface to around 80. And temperature decreases with altitude. In that one, a temperature can be negative 80 degrees Celsius, yes, which is excessively very low temperatures. And upper limit is the mesopause. I think that is clear. We said after every layer, the upper limit boundary is named after the name of the previous layer. So the layer concluding the mesosphere is the mesopause. Why is it important to have the mesosphere in the Earth structure? Is it prevents rocks from space entering the lower atmosphere. Right, there are some dangerous phenomena which may develop from the space which are likely to affect human activities on the Earth's surface. Like, for example, rocks are fragmenting from space. They are filtered by the presence of the mesosphere, such that they do not cause harm within the troposphere and ultimately to life on the Earth's surface. Then we go on to the fourth layer. And this fourth layer, remember, it comes after the upper limit boundary of the mesosphere, which is the mesopause. We go to the thermosphere. It's an outer layer of the atmosphere. It extends from around 80 to merge with the space. which means we will be now going outside the Earth's structure, we'll be going into space. Temperature increases with altitude, and air particles reach temperature of about 5,000 100 to around 1,800 degrees Celsius, which means the temperatures in that particular thermosphere, they are very high. Imagine a temperature of 1,800 degrees Celsius. That is very high a temperature, right? And why is it important? It absorbs high energy radiation from the sun, right? We talked about atomic oxygen. That atomic oxygen within the thermosphere is responsible for absorbing some of the high radiation which comes from the sun. And also it prevents rocks from space entering the lower atmosphere, like what we mentioned in the mesosphere. Right. Then lastly, we look at the exosphere, which is now an outer layer of the thermosphere. We are now out of the Earth's structure. We are approaching space. It's from 550 kilometers to thousands of kilometers into space. We are now getting into space. Right. Why is the exosphere? Exo, we are saying we are outside the spheres, out of the spheres, out of the normal spheres which make up the Earth. So why is it important? It is here that satellites orbit the Earth, right? When you do geographical information systems, you are going to look at satellite images. You are going to look at satellites, how the information on Earth is captured using the satellites. Those satellites, they orbit within in that exosphere, so that they have a clear picture of whatever is happening on the Earth's surface. They capture information from the outer space. So basically, that's the picture of the composition and the structure of the atmosphere. We looked at the structure and the composition of the atmosphere, right? That marks the end of our discussion. We thank you for attending. And what is going to be the core focus area in the next discussion is we're going to focus on the heating of the atmosphere, the process responsible for the heating of the atmosphere. That is the next discussion to follow from this one. So for today, I thank you.